Good morning, everyone. Welcome to the room. We're just going to wait 1 or 2 minutes before we kick off our webinar for a few more people to filter in. Okay, I think I will slowly start kicking off our meeting this morning. So welcome from my side. My name is Lee Estrelado, and I'm here representing ETIP Hydropower today. We are starting now a webinar on the white paper recently released by ETIP Hydropower titled Hydropower's Key Role and Flexibility in Storage for a Safe, Clean, and Secure European Power System today and tomorrow. So thank you to all the participants joining us here today and those filtering in still. Just one word towards housekeeping. The microphones and cameras are off, as you probably all can see. If you have questions in the presentation or also at the end of the presentation, feel free to write them in the Q&A box, which you can find at the top of your Teams screen. There's also chat, but we would prefer if you kept the questions in the Q&A box, and then you can use the chat for sharing any other information. So just a bit of housekeeping. And in the question and answer section at the end of the presentation today, you can also raise your hand, and then we can also directly grant you access to your microphone and video if you would like to say your question directly to us via voice. So now moving forward to the webinar, I will give you a quick introduction to the ETIP Hydropower for those of you who maybe aren't so familiar with it. Then we will get into the discussion of the actual white paper, which I think is why everybody is more or less here today. And then finally, we have a discussion section at the end where you can present questions if you have any regarding the white paper or the process or any of our key findings. So a bit of an open-ended part for you to voice your thoughts or questions. So without further ado, our first point, as I mentioned, is the introduction of ETIP Hydropower. So I think most of you in the room already are aware of the objectives and activities of ETIP Hydropower. But basically, we are a European and funded project that is looking to enhance and disseminate research and innovation, as well as strategic topics related to hydropower, considering the future needs of the sector in regards to research and innovation, and also emerging policy priorities. ETIP Hydropower also has been consolidating the network of hydropower experts and stakeholders that was developed in Hydropower Europe, which was the former project before ETIP Hydropower, with the idea to unify the voices around hydropower in Europe. Again, it's a European funded project. You could find all the information below on these slides, and you can see the project partners involved in this current project. So maybe more interestingly to the current actions and what's been done in Egypt over the last 3 years, we have an operational structure in place, which is run by the Secretariat and those partners mentioned before. We also have now, since a year or two, the governance structure in place, so an industry-driven governance with all stakeholders from the hydropower sector and related sectors present in this governance. We have a governing board with 26 members, chaired by Dennis Albrecht from EDF and also co-chaired by two colleagues, Antonella and Peter from Italy and Austria, respectively. So I think we're quite proud of this governance structure that we have in place so far. It's really a wide range of stakeholders represented, and so far it's been a great platform for exchange and discussion in the hydropower sector. Some other interesting work we've done is released a product called HERI, which is a platform for sharing research and innovation activities that are happening in hydropower. So I encourage you to take a look at that. It's a great way to see what's going on and what has happened as far as research activities. You also can find there organizations that are active in research in Europe. So highly recommend taking a look at that website. One thing I guess I didn't will be available after the presentation on our website, as well as the recording, I believe. So you can find all this information also after the meeting and webinar today. Now, going to the working groups, the other big action that's been happening in ETIP Hydropower, we established 4 working groups last year, covering various topics from flexibility and storage to biodiversity and climate change, and also a working group that's targeting past and current European research projects to help further disseminate their results and information. So these working groups, as I mentioned, are a really big part of the ETIP Hydropower structure and have been working over the last year on developing white papers, as well as videos. And today, of course, we're here to discuss the Working Group 1, which is hydropower's role for flexibility and storage, and the white paper that they developed and worked hard on over the last year. So without further ado, we will get into that discussion now. And this discussion will be moderated by Edward Duyok, who is the Working Group 1 chair, who's also a professor at the University in Vienna and holds a lot of other roles in European projects, as you can see. And then we will also be supported by Irena Belorushka, who is the vice chair of our working group, one of the 2 vice chairs. And she's worked in the hydropower sector as well and is currently pursuing her PhD at the University of Sofia. So without further ado, I will leave it to Irena first to jump in and start introducing the white paper that we've developed, starting with a bit of the context. So please, Irena, the floor is yours.
Thank you, Lee. Also, I'm not sure, but I cannot see the slides. I hope that everything's well and the problem is with me, okay. Maybe. Okay. But okay, indeed, thank you, Lee. And I was privileged and happy to co-chair this working group and also to lead the economic aspects subgroup. I think the context is clear. The power sector is undergoing an unprecedented transformation driven by the unprecedented growth of wind and solar in the grid. So this white paper was written to answer this pressing question: what comes next when the wind isn't blowing and the sun isn't shining, and showcasing how hydropower and also pumped storage hydropower can provide flexibility and storage our power system urgently needs. So it brings together expert research, case studies, and policy analysis to guide decision makers on the needs of the hydropower industry to unlock its full potential to continue to support the energy transition. Next slide, please.
Yep.
Well, flexibility as a notion was formally acknowledged in the recent policy and legislation packages. It was legally defined in the so-called new electricity market design regulation, which entered into force the summer of 2024. It requires a flexibility needs assessment on the daily, hourly, seasonal power system needs. As you would see, hydropower is uniquely positioned to respond to the full range of system flexibility needs. Next slide, please. The methodology draws on scientific and technical literature and also reports from the International Energy Agency, the International Renewable Energy Agency, Euroelectric, the X-Flex Hydro Project, expert input from ETIP Hydropower members, and many more. It also considered new policy documents and regulations like the European Green Deal, the Clean Industrial Deal, the revised electricity market design, and more. It collected case studies of flagship hydropower projects such as COP2 in Austria and Grand Maison in France, which demonstrate real-world flexibility and storage capabilities. Last but not least, we carried out some market analysis of the ancillary services market regarding frequency control, reserves, black start, storage capacity, which can be provided by hydropower and pumped storage hydropower plants. So the process involved synthesizing existing research, policy frameworks, and operational data into a coherent set of insights and recommendations. The white paper provides both a diagnosis of the challenges and a roadmap of the solutions. In summary, it clearly articulates that hydropower and pumped storage hydropower are indispensable for the decarbonized power system. Against that background, now I'll hand it over to our working group chair, Professor Edward Duke, who will take us deeper into the specific findings and recommendations. Edward, please.
Okay, thank you, Irina, for the first part. Yeah, as you have already heard and seen, and I know pump storage, if I look to the audience, should be quite well known. Supports, of course, the electricity grid, the stability of the grid, and what Irina mentioned, what will come in the future, and how to deal with that. We know that pump storage, and we see here one of the examples which have been mentioned in the white paper. Its COPS2 was built in 20 years ago, or started 20 years ago, 2005, and then went in operation, I think, 2007, roughly around this area, and was and is one of the really fantastic units, a ternary setup, which means we have a separate turbine, a Pelton turbine, and then a motor generator and a storage pump, and is, let's say, from the fast ramping machine, one of the really outstanding machines, can be switched between turbine and pumping mode in 40 seconds. With the hydraulic shortcut system, which is included, and of course, let's say, regulation capabilities with Pelton, where you really can go very down in the part load range, very deep part load range, which is quite useful. Yeah? So from that time, I think this is a very good example. It's not the only example anymore. Yeah? There are others as well. But at new build power stations like Nanterons, or also the second power station example we have here, the pump storage is really needed in the energy system at the moment. We see already here, and I know from, let's say, my contacts to Ilwerke, that this power station is running more than you normally would wait for that. It's a few thousand hours per year running and providing here, let's say, services to the grid, Austrian and South German grid. Can we go to the next slide? Yeah. And I think that's having this power station in mind, and what is more to be debated and to be discussed is, let's say, the role, what hydropower can really provide. And that's not always known to all stakeholders or all parties in the energy system. Grid, let's say, we are talking here of grid operators have to rely on different services coming from very small time scales in milliseconds, where inertia plays a role. So also larger power stations, also hydropower stations, have to provide some inertia in milliseconds, which is done then by the, let's say, the generator. And then additional, let's say, products, live FFR or FCR, containment reserves, and down to let's say longer services where we switch a little bit between, let's say, flexibility and storage. Yeah. Of course, I mean those things here, if you see, come always with the challenge or the possibility of turbining or pumping or switching in between. And to be done in seconds or in minutes is possible. That's what we know. But in seconds, this is quite a big challenge and a big stress to the machines and to the units as well. And you see going FFR, this fast frequency response, this is still, let's say, under consideration. Innovating on that, but not really at the moment provided, because if you think in seconds, in a few seconds or part of seconds, then the machine needs to be synchronized. The machine needs to be already in place on the grid. And then you can, let's say, just load changes can be done. But if you go down to very deep part load changes, then of course the, let's say, pressure pulsations out of the flow and specific flow phenomena result in pressure pulsations, heavy pressure pulsations, and this ending up in dynamic stresses, mechanical stresses, which fatigues the unit or the runner. By the way, COPS2 already replaced the runner. I know that was in the last 2 years. I think the runner have been replaced. So you can imagine that not even 20 years of a lot of load cycles led to the fatigue of the runners. And that's one thing to have in mind, especially if we are talking later on research and innovation, that those, let's say, services provided for the grid come with of course with the aging of the units, come with the aging of the components, and have to be taken into account, have to be designed in future, probably a little bit different to deal with that. This is on the short, let's say on the short time schedule, where the machine had really a lot of stress. In the middle, let's say in 15 minutes here, 15 minutes or more than 15 minutes, this is the playground where turbines have already been operated in decades. And then we come on the other end, where pump storage acts as a storage, and there is the question then of storage capacity. And here we are talking of, let's say, storage capacity in the minimum of minutes or hour. But this can also go into days, a daily storage, a weekly storage, a monthly storage, or in the longest range on a seasonal storage. So where we have a time schedule then of half a year. So really to store, let's say, energy in summer when the sun is shining and you have a lot of sun, and then providing electricity in winter, for example, if there is no sun there, no contribution of the sun. It's a little bit different. This is a general, let's say, general matrix or general table here. But you have to consider that in Europe we have differences. We have at the moment also a research project running where we are looking on that and let's say storage capacities in different power plants in different regions of Europe. That's the more north you go, the less contribution of sun of PV you will have in winter. In the south, it's again different. There you have a contribution of sun all over the year. or most of over the year, and then let's say wind, for example, is a little bit changing. So the storage part, the flexibility, and the storage part are the role of hydropower, especially of pump storage, but not only. Yeah. So there is, we'll say, we will come later on to the point where to seek new storage possibilities and where the research should go in. A big portion is also, I think, the black start, which I wouldn't say this is neither flexibility nor storage, but it's a key function or let's say important asset if the power station is able to black start. Means what we have seen in Spain this year and already previously, that if there is really a major blackout, then of course the say restart of the entire grid is not so easy. Especially here, hydropower can play a good role if the power station is equipped with that. Means you have to take care already in front of the functionality that black start capability is there. Means basically you need a kind of let's say easy explained, you need a kind of extra internal electricity source to run your oil hydraulics then, and to, let's say, to be able to open your valves and so on to start the machine. If this is possible, this can be done by, I don't know, batteries. This can be done by smaller Pelton turbines. I know, for example, in Kaunertalkraft power station, they have a small Pelton turbine which can, say, supply electricity for the power station in order then to run the bigger machines. Or you can do it by batteries or even by diesel generators or something like that. But you have to take care that that you have these devices and this, let's say, yeah, parts available, and the machine is already possible to run then in black start. If, let's say, the devices are equipped with that, then you are pretty fast with, let's say, the resettling of the grid. And we have seen, I think in Spain it was 6 hours or 7 hours, or within 1 day at least, that that all customers have been attached again or supplied with electricity. If you look to other blackouts, like in America, where 2 days, 3 days there is no support, then it's also critical. Also from a, I think also from a social part of view, it's quite important to have a quick, let's say, grid support again, because after 3 days you have quite also social issues. That's for the importance of the role. I think this kind of table, which are this box, is quite impressive to know what hydropower can provide and where the services are. And I think those services are not always remunerated in all countries. So this is still a big point, which Irina already mentioned, that there has to be probably something done also on a policy level later on. Okay, can we switch to the next slide? Yeah, the key takeaways from this white paper. I mean, the white paper is not now a research project with a lot of totally brand new, groundbreaking outcomes, results. It's more or less a very comprehensive document to showcase, let's say, where the role of hydropower, where hydropower interacts with other sources, and has the advantage of, yeah, flexibility and support the grid, and that's what we know. We see, let's say, in future, more the fast ramping. That's what we already know. There are, from the technical point of view, already specifications on the market. What I've seen with 30 start-stops a day, and the machine should last 50 years. This was a storage pump in Austria. So there is quite a lot of interaction in the machine, a lot of load cycles to be expected in future, and it will not be better. So that's where we see the role and, let's say, the requirements for the future. If we go, or if we take in consideration also those policies, clean energy transition, net zero, then this NZIAC, so where also the industry should be green, on renewables. So the demand on electricity will raise. If we go in this direction, will raise, and has to be supplied. But hydropower plays their role in this supply, but a more I think even more important role than in the stability or services for the stability of the grid. So to really to come in future also with let's say market perspectives and chances for the hydropower, it needs also some money, some investment in the research. That's where we are. To go into the research, it needs more investigation in terms of this fast ramping of the, let's say, degrading or aging part of the machines. Goes in the direction also of flexibility, of course, which service is needed, depends also on probably local energy production, local demand, how much demand is there, how much storage capacity is there. And of course, those things have to be somehow also remunerated, in any case. So that will be the future. Hydro in as counterpart or complementary part with other sources. That's what we see already in the research calls. Still, I see that in these hydropower calls, what we have in the Horizon Europe program, we should encounter a lot of things from the technical perspective, from the environmental, from the climate change plus social. Sometimes I miss a little bit, let's say, the more technical issues. Even if we think that hydropower is a mature technology, we last on this technology probably 150 years for electricity production. The new challenges and the new services what hydropower should provide needs more investment in research and development and innovation, of course. Good. I think this is basically the key takeaway. So we see a change. We see a unique position of hydropower in Europe, but not only in Europe. I think that hydropower is one of the, let's say, markets probably in Europe where we are competitive to other regions in the world. Still, I think that we have here quite good research, quite good innovative products and innovation. We should take care that this is not stopped somehow, and we are not losing playground towards other regions. Can we go to the next slide? Yeah. Research innovation, what I already said, strengthen here research and development, put a little bit more investigation in that points, and also more money on the table for in-depth research. Then integrated in system planning, as I also mentioned, in energy, in different energy systems. And then looking probably also more on storage possibility, not only on a country level, but also on a regional level. Means also these cross-border interactions will be more, will come up more. Okay. Yeah. In terms of policy, what I already mentioned, here we should probably think a little bit on different situations at the moment in different countries. It's a very sensitive topic, I know, but still, if we start then thinking on larger regions and interconnections, then we also have to think probably here also to update policies and regulations in that. And of course, we need a market and investment, so this should also be secured here, not to forget that at the end you can only invest in innovation and in research, of course, if you earn some money and if you have some money, that should be not forgotten from the perspective of the research. Okay, it's clear. From company point of view, of course, markets should be there. Good. I think that was the more or less from our side. It's the last slide. We can go over. We have a 15 minutes Q&A now. I would say we start with that. I don't know if there are any questions already there, or Lee. I will hand back to Lee as the main moderator.
Yes. Thank you, Edward, for that discussion, and also to Irena for the earlier discussion. As Edward mentioned, we have about 10-15 minutes for questions. If there's questions in the audience, you're welcome to write them in this Q&A section of the Teams window, or you're also welcome to raise your hand. So if there are questions, please feel free to indicate that now. We have one, I believe, already.
Wolfram, you can speak. You have access to the microphone now.
Okay. Yes, I have a question to Edward. Edward, thanks for the excellent presentation. I have a question. How would you assess the advantages of or difference between pumped storage and battery storage? What's your assessment of these two technologies?
Yeah, well, thanks. Good question. Yeah, it's a very often discussion. Do we need pump storage with high investment? Can battery solve this as well? At the moment, if you look to the installations of batteries, and I know they're going quite large in terms of power, we have always to distinguish here a little bit between power and capacity. The power of batteries can go up to 100, 200 megawatts already, I think, which are installed in Germany somewhere. But then is the question, how long is the storage capacity? And most of the time it comes up with 1 hour to 2 hours. And that's, I think, a little bit the difference. Of course, we know that the battery can react much faster, can go in this FCR in milliseconds or in parts of seconds, where hydropower has still a problem. But I think if we go on the other end of the time scale, the longer you need a kind of electricity supply from a storage, the more advantage comes from the power from the pump storage. That's the capacities are still in the bigger reservoirs, I think. Yeah, if you consider if you have a blackout, I mean, and then 2 hours in a blackout is nothing. Yeah, I don't think that you can restore an entire grid only with batteries, which is probably also not needed because you can then start, but then it's a combination again. Yeah, it's a combination of starting machines. I mean, if we think on other technologies as we have at the moment, thermal, coal, gas you can also start probably in half hour to an hour, but other primary sources needs longer. Yeah? So a combination between, and that's what we already have and see, and there were some projects, flexibilization projects, combining batteries with hydro makes quite a good sense, I think. And you need also maybe less investment in batteries. Batteries are quite expensive. I mean, they are dropping with the price because of mass product, but still, if you need a larger capacity, still there is a big investment. Yeah. It's hard here to see what comes first, what is better. I think in future we need all things. I don't know if this answers the question, but that's how I see it at the moment.
Yes, thank you. You answered my question. Thanks.
Perfect. Thank you for the question, Wolfram. We have a second question that was posed in the chat from Robert Sonoga. And the question to the group is, in your view, what the most effective mechanism is to attract investment in hydropower and keep it competitive, whether that be targeted subsidies, market reforms, or direct government support?
Mm-hmm. Maybe Irina, have you?
Okay, thank you, Edward. I think, well, this is actually a question that we have discussed really comprehensively within our working group. And well, basically, we didn't call for any subsidies or direct support schemes in this paper, which was meant to be consistent with the overall messages that we wanted to give within ETIP hydropower. But I mean, we need to consider several aspects. So first, the new market design regulation, the new market design framework that I mentioned entered into force last year. Actually, I don't want to use this word excluded, but this actually happened because the hydropower and pump storage hydropower with reservoirs and pump storage hydropower are actually not eligible for the direct support schemes that were mentioned in the very regulation. So basically, we cannot. We as hydropower cannot enjoy these straight contract for differences and the similar support schemes. So on the other aspect, so the point that the mechanism that was left to hydropower was actually because of this unique flexibility and the multiple aspects of flexibility that we also discussed extensively in our working group. So most likely the path forward for hydropower would be once all the flexibility needs assessments, the national reports are ready, and also the European one, the respective member states would be able to put in place the non-fossil flexibility support schemes. And this would be the unique proposition for the pump storage hydro and the flexible hydro and reservoir hydro also. So this is the current situation. So from such a perspective, I think as hydropower, we would pick any of the support schemes that were put in place promoting, for encouraging long duration energy storage, and try to adjust them to the specific needs and the really specific aspects of hydropower. So in our working group, we discussed really extensively. We even some of the colleagues put forward this multi-purpose flexibility concept. So actually, we discussed the really full range of flexibility that hydropower would offer. So I think the point is that we would have to we would pick any of the most suitable long duration energy storage support schemes and try to adjust them for the needs of hydropower. So I hope that I responded to this question.
Okay, thank you for that. We have, Edward, did you have something?
Yeah, I mean, that what we discussed today was only, let's say, from the technical point of view. Yeah, hydropower, if you say put hydropower in the water, energy, food, and so on nexus, there's also water involved. There's water for agriculture, water for drinking supply, and so on. So that's what Irina also mentioned, this multi-purpose advantage of a hydropower plant is still, let's say, we put a part beside which can also be provided or taken into account.
Yeah, absolutely. So there's not too much time left, but there's still one more question. So I think we can take this last question before wrapping up. And it's kind of a two-part question from Andrea Battaglia. And that is, what is needed for hydropower plants to reach black start capacity? I think you touched on this already, Edward. And then also the question there was, can hydropower plants compete with new battery technology? Would they compete for the same revenue sources, or would they split themselves between short-term and long-term storage? I think you mostly answered this question, but if you have another word or two.
Yeah, I mean, what does it need for black start capability? And if you consider that there is no grid supply, yeah, I mean, if you start a hydro machine, a unit, you need, let's say, open a valve to start water to flow. You need to open the guide vane. You need, let's say, the bearings supplied by oil. What you definitely need is a little bit of energy to start your oil hydraulics in order to prepare the machine for turning and to open the guide vanes with a hydraulic cylinder. So that's definitely needed. Sometimes it needs also a little bit of, let's say, sealing, cooling, and so on. But these are specialities. Most of the time you need the oil hydraulic. If that is not, and if you don't have any supply and foreseen big enough supply to do that, then it will be quite difficult to start a machine, those bigger machines. Yeah, in terms of competing battery versus hydropower, yeah, I mean, there's always the same market. Is the grid operator, which offers the market for the secondary control. Primary control is still done with specific machines, and there is no open market, really open or stock market for the primary control. Here we will probably see maybe a battle or a combination in the future. I think that also battery alone will not solve this issue. At the moment, it's seen like, yeah, hurrah, yeah, we can solve that. If you look a little bit further, and what we are working already in a project on to look if you are increasing, let's say we just made a short use case in example, if there was in Spain, let's say a river, yeah, where you use a river stretch for storage and have a power plant. At the moment, the power plant and the reservoir there, let's say the storage is used 2-3 times a year, yeah, for storing, for example. But if you there is at the moment 1,000 megawatt of renewables there, of wind and solar. But if you add 2,000, and this is already, let's say, under design and the projects, it's not installed, but it's already in the preparation phase. So adding 2,000 megawatt additional wind and solar, then it changes. Yeah? Then we see that this storage is needed every day nearly. Yeah? So there will be quite a interesting need of storage capabilities in the future. Yeah? If you think on really renewable, more renewables as we have. Yeah?
Perfect.
Okay.
Yeah, thank you for that, Edward, and thank you for the questions in the audience. So as you can see, we're about at the end of our presentation. So I think I will wrap things up now. But of course, I want to thank everybody in the audience for attending and also your engagement and questions. Of course, thank you to Edward and Irena for your support and the moderation here today and for sharing your expertise and also insights into this white paper that was produced by ETIP Hydropower. And I also wanted to, of course, thank the Working Group 1 members who were very, very active over the last year, basically, working on this paper. I think it turned out to be really great, and we're happy that we are able to publish that to share with you all. And thank you to the support, like Iraya, for help setting up this webinar and having things run smoothly. So as a reminder, please feel free to share this information with your network. We will post these informations online after. You can find the white paper on our website as well. And you can also find the next white papers that ETIP is releasing on topics like biodiversity and climate change. Those should be coming out in the next 2 months or so. So please keep an eye out for that. And yeah, share the message, look us up on social media, look at our website, and please keep ETIP Hydropower in mind. It's an important topic, and we look forward to continuing the discussion on it. So thank you all for your time today. And I think we will wrap things up now, but we hope to see you online or in person in the future. So thank you, everyone.
Thank you.
Thanks.
Thank you.